Welcome to this Follow the Wire video for our OEM customers and partners. In this session, we're going to discuss NVMe over Fibre Channel. As discussed in our video on NVMe over Fabrics, there are two main choices for server to shared storage connectivity. Those choices are Ethernet and Fibre Channel. Now, each of these use SCSI storage protocol today and are transitioning to NVMe protocol to support connectivity to all flash storage solutions. In a traditional SCSI SAN, we have application servers with Fibre Channel HBAs connected through Fibre Channel switches to SCSI-based storage arrays. Read, write, and other commands are sent across the SAN between the server and the storage. These commands are embedded in Fibre Channel frames. There are different elements that make up the Fibre Channel frame itself: startup frame, header, a data field, CRC, and end-of-frame sections. The key for a SCSI-based SAN is that the SCSI commands are embedded in the data field. With next-generation FC-NVMe SANs, everything is the same except the NVMe commands are embedded in the Fibre Channel frames, and the storage array needs to be able to understand those NVMe commands. Note that the core infrastructure, the HBAs, the cabling, and the switches in the SAN don't change at all to make this transition from SCSI to NVMe. This makes the transition to FC-NVMe-based storage arrays rather simple. The next generation FC SAN will be passing these NVMe commands across what is essentially the same fabric that was used in the SCSI-based SAN. For support of FC-NVMe, the FC fabric must be made up of 16 gigabit enhanced Fibre Channel or later generation Fibre Channel components. That includes HBAs, switches, and the target array adapters. It's the 16 gig enhanced point in the Fibre Channel roadmap where support for NVMe came into being. In addition, there must be support in the operating system for FC-NVMe, and customers need to have a storage array that supports native FC-NVMe connectivity as well. All QLogic QLe2690 series, QLe2740 series, and QLe2770 series HBAs from Marvell support not only FC-NVMe, but they also support FC-NVMe version 2 with enhanced error recovery. Fibre Channel infrastructure in general, and specifically Marvell QLogic HBAs, provide simple integration for these next-generation NVMe arrays. We have an existing SAN fabric here connected to legacy SCSI-based Fibre Channel storage. Now we want to add new NVMe native storage to the same fabric. These arrays connect via FC-NVMe to the existing Fibre Channel switches and directors in the fabric. No real change to the switch hardware is required, assuming that you're running a switch with OS from the mid-2021 timeframe or later. New storage can now be seen in the fabric just like the legacy storage. On the host side, the good news is that 16 gig enhanced and 32 gig Fibre Channel HBAs can support concurrent communication of both SCSI and NVMe commands on each adapter port. So the host can connect to the storage using the existing HBA in most cases. Where complexity comes in is in the driver design. With Marvell QLogic Fibre Channel HBAs, the HBA driver supports both Fibre Channel SCSI and FC-NVMe today, a single driver for both. Competitors require customers to add a separate FC-NVMe driver to support connectivity to the FC-NVMe storage. This is an extra step that the administrator needs to take on each server in the SAN, and that simply isn't required with the Marvell QLogic technology. As with any new technology, it takes the OS vendors a while to incorporate all features and capabilities. FC-NVMe is no different. The QLogic team at Marvell takes care to document any limitations in our user's guide. For example, in the current QLogic Fibre Channel HBA user guide, you'll find a list of limitations and known issues in the FC-NVMe section. That's shown here. Now, for example, you can note that for Linux, the OS has an issue related to rebooting the server today. Linux OS vendors are working to address this issue in future releases. But if the server needs to be rebooted today, It's recommended to disconnect the storage first. Instructions for the commands to issue to accomplish this are also in the guide. If you don't disconnect the FC-NVMe storage first, when the server is rebooted, the storage will not be visible, and this just creates issues for both your server and storage administrators. So yes, when using new technologies, practice RTFM. Read the freaking manual. This slide was shown in our NVMe over Fabrics video, but I'm repeating it here to show the benefit of transitioning to FC-NVMe. As you can see, there's a 28% reduction in latency, and the IOPS performance is comparable to local NVMe storage when you're using FC-NVMe. This means applications run faster when compared to FC-SCSI. Let's use some data from one of our OEMs to prove this point further on the next slide. Here's data that was presented by the folks at Hewlett-Packard Enterprise at SNIA's Storage Developers Conference in September of 2021, showing performance of Fibre Channel SCSI or FCP versus FC-NVMe with machine learning workloads. The HPE team ran training data sets of different sizes in both VM and container environments using both FCP and FC-NVMe connected storage and compared the results. As you can see, the workloads completed in a shorter amount of time with FC-NVMe. Run times were reduced by as much as 35% depending on the size of the data set. Bottom line is, FC-NVMe will allow more work to be done in less time. So now the question is, why use QLogic Fibre Channel HBAs for FC-NVMe connectivity? Well, here are the key differentiators. The QLogic HBAs are easier to deploy with a unified driver. System admins don't need to waste time loading extra drivers and servers just to support NVMe storage. QLogic HBAs are fully integrated with both Brocade and Cisco switches and directors. All the features are supported in both fabrics. QLogic's port isolation architecture ensures predictable per-port performance. That's something competitor offerings cannot guarantee. QLogic HBAs are secure with hardware root of trust and the ability to support encrypted data in flight in select models. QLogic SAN congestion mitigation technology helps address slow drain issues in real time. All features are standard in the firmware, and there's no extra software licenses to buy like with competitor offerings. And QLogic's QConverge console is available to integrate into VMware and Windows System Administration tools to simplify management at no extra cost. Also available in PowerShell Kit and CLI format. Here's the portfolio of QLogic Fibre Channel adapters from Marvell. QLE 2690 series are our enhanced 16 gig Fibre Channel offerings. The QLE 2740 series are our standard 32 gig Fibre Channel offerings, and the QLE 277 series are the enhanced 32 gig Fibre Channel offerings with additional features like hardware root of trust and support for PCIe Gen 4. All QLogic adapters shown here support FC-NVMe and are fully integrated with both Brocade and Cisco Fibre Channel SAN switches and directors. So here are the key takeaways from this session. FC-NVMe is here today and the most mature of all the NVMe over fabric transports. FC-NVMe delivers significant performance increase over traditional SCSI-based fiber channel networking. QLogic Fibre Channel HBAs make the transition to FC-NVMe easier than competitors and offer more features to support high-performance FC-NVMe environments. That's it for this session. For more information, go to www.marvell.com/QLogic to find out more on Marvell and QLogic Fibre Channel HBA technology. And be sure to check out our other Follow the Wire videos on the Marvell YouTube channel. Thanks for listening, and have yourself a wonderful rest of your day.